So you're with Arno Destiné. I'm working for the French company Trinnov Audio. I'm in charge of international sales. We're here at Mutrox in the Netherlands, an acoustic design company, working hand in hand with Bowers Wilkins, Netherlands. So we are announcing this new partnership with BMW, who is now distributing our home cinema products.
Yeah.
So we're very happy to be here. For different reasons. First, we're very excited about this new partnership because we have on one hand BMW, which is obviously a well-known and established company, especially here in the Netherlands.
Yeah, they are.
We know they have extremely good relations with the dealers and home cinema installers. Yeah. And we're also very excited about the fact they're working with Mutrox. Because when dealers come in today so that we can introduce them to our products and our philosophy, we can explain them our view on how a room should be designed, because it's not only about the home cinema processors you install, obviously.
No.
A lot of people are left to think that because we're an recognized expert in loudspeaker room optimization, we should not really take care of the room design and the acoustic.
No, that's one thing I noticed when I reviewed the Amethyst. We spoke before this, and I said a lot of people think they fix things, but you said no, it doesn't fix things.
Well, it does, but it's not essentially here to fix things.
No.
What we want ultimately is the best performance for our customers, because obviously it's a significant investment, especially when we're talking about the Altitude 32.
Yeah.
So the Altitude 32 alone will fix some acoustic problems, but that's not the way we hope our dealers think. We want them to be professional beginning to end of the project.
Yeah.
Designing the room in terms of proportion, loudspeaker placement, screen width, viewing angle, listening areas.
Yeah.
Every single parameters matters.
Yeah.
So if they expect to have a bad design, throw in an Altitude 32 so that it fixes everything, definitely that we're not at the same page. And obviously we want to work with dealers we're comfortable working with because we know they will deliver the performance we expect from them, and that the customer expects from such a solution.
So even you think that you should start out with good room acoustics, good proportions, good speakers, good amps, everything, and then dot the I's.
Absolutely. It's mandatory, and I want to make that really clear. That's what Trinnov is saying everywhere. So we're going around the world training our dealers, sometimes calibrating systems, so we can see whether the dealer is professional or not. And I can tell you the dramatic difference there is between a room that has been badly designed and a good room. And it's day and night. It's not acceptable to start a calibration when everything has been done wrong in the first place. And that's the case in commercial theater, in professional studio environments, in hi-fi rooms. So the audiophile market is different because that's something people don't really accept yet, that acoustic matters at least as much as the equipment they're using.
No, I think it's starting to get there.
Hopefully.
In the Netherlands you see a lot more about room acoustics and treatment of rooms, and I think that's a good thing because it's 50% of your sound. That's what we think.
It is, absolutely. So here we're hoping that the reaction from dealers is going to be good. We just listen to the system. Of course, with Mutrox professionalism, it's a very good starting point.
Absolutely.
So the amount of work that has to be done to fine-tune the system is much less when you start from somewhere really highly performing already, which is the case here, both in terms of soundproofing and acoustic treatment.
Do you think the Trinnov systems will perform better when the room is better? So they don't have to calculate that much, maybe? I don't know. Filter less?
That's a tricky question. It depends which way you're looking at it. If you want to get the biggest wow effect when you switch the correction on and off, maybe it's better to start from a bad design, a room with massive problems. But once again, it's not what we're trying to achieve here. We're trying to achieve the best
performance.
So even though the effect is not as big, starting from a small room from a properly acoustically designed room, and then implementing our optimizations, is still the right approach.
Okay.
At the end of the day, it's as much loudspeaker room optimizations, trying to compensate for acoustic problems, but it's also very much about controlling the speakers, making every speakers in the room performing in a consistent way.
Yeah.
So that's something you cannot really achieve with acoustic treatment.
True.
So it's really controlling the system, driving the system so that it delivers the best.
Yeah.
Whereas the acoustic treatment is just making sure that the fundamental mistakes are gone.
So whatever you do on the volume level, you have the maximum performance in terms of amplifications. By doing these adjustments to perfectly align, we reduce the gain on the power amp, and we also effectively lowered the signal to noise ratio. I think it's close to 120 dB, which is really high. It's using the HyPEX module NC1200, so we have effectively 8 channels and 8 modules of 1200 watts Class D amplification. We cannot deliver 1200 watts continuously, of course, having so much power coming off the wall, but nevertheless there is 2 power inlets, so we effectively have 2 4-channel power amp in a single box to be able to get more power out of it. First, you may have seen this microphone, so that's our own design. I think that's the most iconic object to define what Trinnov is, and that's something very special that no one else offers. Why do we use these 3 capsules? Well, that's obviously to gather more data from the acoustic measurement, and we use this data to apply some of our proprietary technologies. I will get back to this, but powerful multidimensional analysis and alignment. Yes, it's not only an EQ. We're not only looking at the phase response, at the frequency response. We're trying to understand as much as possible from the measurement and do as much as possible electronically speaking to improve the performance of the system. So besides the technology, what's interesting is that we've been rolling out this technology across the entire industry. So we know how the post-production studio is calibrated. We know how at Fox, for instance, a cinema mix is translated into a Blu-ray mix, because we work with these people. And then we know how a cinema is calibrated. So at the back here, at the bottom, it's a 800 seats premiere screening room on the Champs-Élysées using a Trinnov. So that also answers another question you may have. Does this technology work for large rooms? Yes, it does. So this experience is very interesting for us to make decisions as to what is right and what is not right to calibrate a system. Going back to immersive sound as a specific subject, loudspeaker room optimization becomes even more relevant, because the more speakers you introduce in a room, the more acoustic problems it creates. So if you have a processor that does apply room correction on only a certain number of channels and not on all of them, just run away. It's the wrong approach. You need to consider the system as a whole, and that's what we're doing by having 32 channels enabled with loudspeaker room optimization. More specifically, what our technology will do in a home cinema. If you have screen channels, surround speakers, and height speakers, most likely they will be of different nature, different design. You will have large 4-way, 3-way, maybe 2-way systems, so different crossover implementation, different phase response, different sensitivity. And yet, at the listening position, you need all these speakers to deliver the same sound quality. And natively they will not, because they are at different distance and the design itself is different. So what we want to do is achieve consistency of amplitude, phase, and impulse response across the entire system. That's something you cannot do with acoustic treatment. And that's why since the beginning of cinema, there's always have been, well, that's not the exact reason, but that's why equalizations was introduced in the first place, and that was a long time ago. So what's special about this technology? We have a very unique multi-point measurement algorithms. So it's not about saying that by measuring different position in the room you're going to enlarge the listening area. No, because that you have to do it with acoustic treatment to make sure that you have a consistent response across different seats. Nevertheless, being able to account for the response at across different seats allows you to do to make the right decisions when it comes to fine-tuning the system. So we have very flexible engine as part of the solution. We provide more acoustic information than any other system on the market. And how can you make the right decisions in terms of fine-tuning and calibration if you can't see the actual data? You can't do this blindly. So coming from the pro market, it was obvious for us that this amount of data had to be also available to home cinema installers. And in terms of algorithm, the difference between an EQ, which is fairly simple, and the kind of technology we're developing is that there is some intelligence because we account for the time domain. We're able to differentiate the influence and the contribution of the direct sound compared to the audio reflections and the light reverberation of the room. That's because we analyze the sound over time, so we can really go fairly far in the analysis and apply the right and specific technologies to address each of these problems individually. So that's where the intelligence and the extra capability of such a system are over traditional EQ or more less sophisticated optimization solutions. And then AOIP, you may wonder what that is. It's audio over IP. So in the future we will also see a growing number of loudspeaker manufacturers or power amplifiers manufacturers only needing you to just pull Ethernet cable from the processor to the speaker and controlling everything over the network. There is a number of technologies already installed and in use in the broadcast industry: Dante, AVB, Ravenna, AES67.
Yeah.
So we have Ethernet port at the back of this processor to enable any upgrade in the future in case you want to use that kind of solution.
Is it AES67 compliant already?
Our output?
Yeah.
No, basically it's going to have to be a hardware upgrade depending on which solution you want to go to.
Okay.
But as of now, we're just monitoring the market to see which trend gets successful in the home cinema market right now. AVB is getting an edge, but it's very slow. It's too slow for now for us to make a decision and make a move.
Okay.
But anyway, it will be possible because the port is there. We don't have to make a new hole in the rear panel, and there is already the slot in the whole architecture for that extra board. Even though the Altitude 32 was introduced in early 2014, it's still the only AV processor using an Intel processor, multi-core processor, rather than multiple DSP. And yeah, that's been the major game changer and the major difference with our competitors. Why? First, gives us much more power, and power is needed when you want to drive 32 channels well with sophisticated processing. Power is needed when you want smooth rendering of objects across 32 speakers. If you're limited in terms of processing power, you will have segmented production. We want something really smooth. And then, yeah, for all of this processing, you need more memories. So DSP come usually with megabytes of memory. This kind of processor comes with gigabytes of memory. So it's a completely different world. But there's much more benefits to software implementations as opposed to hardware implementations. And the first being that we don't have to wait for chipsets whenever a new technology comes along. The normal way would be for Dolby or DTS or 3D to first talk to analog device, I don't know, who else, Cirrus Logic or Texas Instruments, and tell them we have this technology we would like to push into the consumer market. Here's what it can do. Please implement it in your chip. So that will take some time, obviously. And then this chip eventually has to be implemented in an OEM board that will then be made available to processor manufacturers. So that's potentially a 3-step product development. Instead, because we're implementing everything in software on top of our Linux-based operating system, which we have optimized for audio since 2005. We speak directly to Dolby, we check their code, and we implement it ourselves. So history have shown that it's actually working, because we were first in the high-end segment with Dolby Atmos. We were first with, we were not first with Over 3D because we were not given the code, and actually there was a product released even before the Altitude 32, but we were first supporting both. And in fact, IAC 2014 was the world's first Over 3D and Dolby Atmos demonstration by the same processor. And CDA next year was the world's first for Dolby Atmos, Over 3D, and DTSX combined demonstration by a single processor. That was also with an Altitude 32. That was, well, more than a year ago, and as of today, there is still no other high-end processor supporting the three formats. So software implementations, faster time to market is not only a gimmick, it actually works, it's a reality. Not only allows us to offer the technology faster, and we all know that customers don't like to wait, especially when they invest that kind of money. So being able to tell them, yeah, just have it. Software, no hardware upgrade, just software update, internet, it's fine. But also we don't rely on the inherent limitations of those chipsets, because those chipsets, for instance with Dolby Atmos, they are developed for the mass market. So the limitation in the case of Dolby Atmos is 12 channels, 7.1.4. No one else using DSP can go above that. So we are doing 32 because, once again, it's our own implementation. So that's what I was explaining you before. You can see that from 12 to 32, that's quite a dramatic gap. But why would we need that many channels? Well, just showing off again, sorry. Why is that important? So Dolby Atmos, as you may know, is object-based. So the same mix, the same Blu-ray, will play the native mix. So what has been intended by the director and the sound mixer across that system or that system, regardless. It will play the same thing. The difference will be the spatial resolution. So if in the mix the intention was to have a rocket flying overhead from front left to the back left, it will happen in this case, going from this speaker to this one and this one, but obviously with far less precision. But it's not the only point. We don't want only to increase spatial resolutions and provide a smoother movements for all these audio elements in the mix. Obviously it's more immersive, but it's all about home cinema. So if you only consider one seat, then you get it all wrong. If you build a dedicated room, or if you have a large living room, then you want a system to perform equally across the different seats. The way this is going to be perceived at this coming from that direction by the main listener is by a nice alignment of the system. So the phantom image will be realistically perceived as if it was coming from here. But if you have two different seats, two extra rows, the person sitting here will obviously hear only this speaker. So the experience is completely different depending on where you sit, and that's what we want to avoid for a good cinema experience. In that case, instead of being a phantom image which moves with you as you walk around the room, it stays there. It sticks to the physical source, being the speaker. So whether you're here or here, the source will always be perceived as if it was coming from that exact locations, which is what was intended initially. So, job done. Here is the real challenge from a technical perspective everybody's been facing. What we call a carrier format in this block diagram, in this signal flow, is Dolby True HD, DTS HD Master Audio. That's one block. What happened with those new formats is that you added one extra block on top of it, and then another layer, a mixer. So you have, instead of only one, you have 3 different layers, ignoring the processing that happens later on. And you have to imagine that you have 3 different blocks like this. One for Atmos, one for Oro, and one for DTSX. So you have to handle every single of these blocks perfectly for the system to decode things right. And obviously none of them were designed to work alongside each other. Dolby didn't make it easy for DTS:X to play well alongside Dolby Atmos. So it's up to the processor manufacturer to make it work one way or another. So we did that well, and as a result, we have the only preamplifier today that can upmix anything to anything. Otherwise it would simply not work. DTS legacy with some processor could only be upmixed using the DTS:X upmixer, and likewise with Dolby. We can we can mismatch the initial source format and the upmixer we want to use. So that's much more flexible for the user if his preference goes to the Aura 3D upmixer, for instance. Then we have the remapping. Talking about these three formats, back in the days of 5.1, 7.1, there was obviously an industrial war. It was between Dolby and DTS, which one of the two will sell the biggest amount of license to Denon, Integra, and Marantz. Yeah. Well, at the end of the day, they all supported both formats, so they both won. But installers didn't have to go through so much pain as now, because it was 5.1 and 7.1, and it was standard, whether you're trying to decode DTS or Dolby. With immersive audio, as you can see from these very basic drawings, the loudspeaker placement recommendations are not really compatible. They're in fact very different. And there is one thing you shouldn't do as an installer, it's to install format-specific speakers. Why is it stupid? It's stupid because most of the time, half of the speakers which are format-specific will not be used. So it's a poor usage of speakers, and therefore it's not really fair to the customer who's paying for these extra speakers. So instead of strictly relying on these specific speaker placement, we created our own recommendation, trying to figure out the best compromise. Because in fact you have a strict recommendations for each speaker placement, but you also have a range of positioning for each speaker which is accepted. So by playing with this range of tolerated angles and positions, we managed to figure out a number of compatible and universal speaker layout for immersive audio where most speakers would be used most of the time. And in a way, instead of installing speakers just to play a specific format, we could install more speakers to provide that extra spatial resolution and larger listening area. So at the end of the day, it's a win-win for everyone. And in fact, once again, the first time we did show such layout was at ISC 2015 with Bowers Wilkins Netherlands and Mutrox. And it was the first time we played Dolby Atmos and Aura 3D on the same speaker layout. So the thing is, we know the actual position of a speaker in a room. We also know the theoretical speaker placement for each given format. So let's say we know the speaker is here, but because on the input we're detecting Aura, we know it should be here. So because we know the exact mapping, and we have this patented technology called 3D speaker remapping, we can virtually replace the sound where it should be, using surrounding speakers. So in fact, the more speakers you use, the better the remapping will behave. So that's one more reason to install more speakers in an immersive audio environment. Well, secret sauce, that's how the stereo file called 3D remapping. I still have a hard time figuring out what that means and whether it's good or not, but it's coming from stereo files, so we have to show it. And that's about it. Now you're kindly invited to enjoy the demonstration and tell us what you think.